Okay, we're going to talk about now spark control. Spark control controls when the ignition is being fired at what time. Here's a basic old school distributor. Here's the vacuum advance, and here's the centrifugal weights, the roller sits on top of. The centrifugal advance is controlled by engine speed. As the engine speed increases, the weights fly out. This arm and this arm comes out. You see the springs right here? And that advances the rotor, which advances the timing. So in this type of spark control, we do it two ways. Centrifugal advance, that's controlled by the speed, and vacuum advance, which is controlled by vacuum through a delay valve, a delay valve, OSAC valve, a thermal vacuum switch. I'll talk about that later on. But this is an earlier version of spark control, either by a vacuum advance unit or centrifugal weights that's controlled by engine speed. Spark control, mechanical advance, vacuum advance, centrifugal advance. Just said that. Electronic control, computer control. Now here is the, let me see, this is 13 RPMs, this is 3600 RPMs. As engine speed increases, spark must be timed earlier. So in this case here, the spark curve is for all timing conditions. So spark control, it makes sure they have the right time at the right time for all driving conditions. So this spark control is basically for, in this situation, for all driving conditions. So read what it says again. As engine speed increases, spark must be timed earlier. So what that means is that the spark curve is for all timing and driving conditions. See here at 1200 RPMs, my curve is about 41 degree travel. 18 degrees before top dead center and 23 degrees after top dead center. Now, at 3600 RPMs, it has to occur earlier because it's moving faster. The piston's moving up and down faster. So it starts at 40 degrees before top dead center and ends up at 20 degrees after top dead center. This never changes. And here's another example of this curve that meets all driving conditions. Here's the RPM here. And here's my crankshaft speed. And here's my timing. As you can see, when my condition changes, my timing curve also has to change to meet those conditions. Here's the vacuum advance unit. You can't see the centrifugal advance on this one, but you see the plate. This vacuum advance has a plate, has an arm screwed into this plate. So in this earlier model, when this throttle is open, I get ported vacuum here. I'm going to send a vacuum signal to the vacuum advance. It's going to pull this diaphragm. This diaphragm with this arm is going to pull this plate forward. When it does that, it advances the timing. Here's the earlier versions, the vacuum advance units. Here's some other spark control systems. This is a delay valve. Spark delay valve. What happens is you get a vacuum on one side, let's say from the carburetor or throttle body. This is the delay diaphragm in here to prevent it from coming out on this end, maybe a second, 2 or 3 seconds later, or half a second later. It depends on the manufacturer. So these actually delay these spark delay valves actually delay the vacuum to the vacuum advance for spark control. So it's called a spark delay valve. It's usually hooked up a vacuum line here to one end of the delay valve and its other end to the carburetor source or throttle body source. Here's another type, thermal vacuum switches, which also delay the vacuum to the vacuum advance. This here assists in the coolant. and it doesn't allow vacuum to the vacuum advance to a predetermined temperature. I have vacuum here, but it can be blocked off if I do a check valve inside. Once it heats up, the check valve is a wax element in here. It's going to push the check valve up. Then it's going to let the vacuum through and out. So these are called thermal vacuum switches. Here's the other vacuum switches. You see electrical signals. Back to the thermal vacuum switch again. We already explained that already. This is early Chrysler's, another type of vacuum control system. Here's the, I think they call this a amplifier. Yeah, it's right here on top. Call it vacuum amplifier, right, on Chryslers. They use this type of spark control system. And here's the OSAC system. I think the old Chryslers used this too. They used the OSAC. It's on the side of the thermostatic air cleaner. You can see it right here also. Which also is these lines, one's coming from the throttle body or carburetor. Well, in this case, it's the carburetor. The other end, the vacuum goes in, then it's delayed, then it sends out to the vacuum advance. That's old school spark control. Here's a newer version, electronic spark control by the ECM or ICM. Here's electronic spark control by a pickle coil, sends a signal to the ignition module. The module sends a signal to the ECM, and the ECM will determine when to fire the ignition circuit. So I think that covers all the spark control items. So remember, the job of spark control is to provide spark at the right time for all driving conditions. And these are I just described some of the ways it's doing that. You just got to remember how it's doing it. Not how it's doing it, but the type of systems that's on different cars. Okay, I'm out. Peace.